Hello everyone, welcome to Curious Quantum channel. We are now going to solve a previous year question from IIT JAM 2025, which is a very interesting infinite series based question of calculus. So let's begin. In order to solve this question, you need to know about Taylor series. The given function is summation n is equal to 1 to infinity minus 1 to the power n plus 1 pi to the power 2n plus 1 upon 2 to the power 2n plus 1 multiplied with 2n factorial below. We have to solve this function. First I will extend it so that we can see it clearly. Now we put n is equal to 1. So minus 1 to the power 1 plus 1 pi to the power 2 into 1 plus 1 upon 2 to the power 2 into 1 plus 1 multiplied with 2 into 1 to the whole factorial plus minus 1 to the power. Now we put n is equal to 2 plus 1 pi to the power 2 into 2 plus 1 upon 2 to the power 2 into 2 plus 1 multiplied with 2 into 2 factorial plus minus 1 to the power 3. We here put n is equal to 3 plus 1 pi to the power 2 into 3 plus 1 upon 2 to the power 2 into 3 plus 1 multiplied with 2 into 3 factorial, and the series gets continued in the same manner up to infinity. Now it equals minus 1 to the square. As you can see, we get plus 1, hence no need this, and this is equal to pi upon 3 pi by 2 to the power 3 multiplied with 1 upon 2 factorial minus 1 to the power 3, which is odd, hence we get minus sign here, and we get pi by 2 to the power 5 into 1 upon 4 factorial. We here get plus. In this series we get plus, then minus, then plus, alternate sign goes up to infinity. Hence we now here get pi upon 2 to the power 7 into 1 upon 6 factorial, and here minus sign, and it tends to infinity. Now you can see that the resultant function is looking like a cos x series function which we get from Taylor series. So the cos x expansion from Taylor series is equal to 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x to the power 6 upon 6 factorial plus, and in the same way it goes up to infinity. Now in this expansion we put x equal to pi upon 2. Now turn the page. We get cos pi upon 2 is equal to 1 minus, we put pi upon 2 in place of x, hence we get pi upon 2 to the whole square into 1 upon 2 factorial plus pi upon 2 to the power 4 into 1 upon 4 factorial minus pi upon 2 to the power 6 into 1 upon 6 factorial plus alternate plus minus sign goes up to infinity and the series continues up to infinity. And here we know that cos pi upon 2 is equal to 0, hence we put here 0. 0 is equal to 1 minus pi upon 2 to the whole square into 1 upon 2 factorial plus pi upon 2 to the power 4 into 1 upon 4 factorial minus pi upon 2 to the power 6 into 1 upon 6 factorial plus it goes up to infinity in the same manner. Now multiply the equation both sides with pi upon 2. We get 0 is equal to pi upon 2 minus pi upon 2 to cube into 1 upon 2 factorial plus pi upon 2 to the power 5 into 1 upon 4 factorial minus pi to the power pi upon 2 to the power 7 into 1 upon 6 factorial plus it goes to infinity. Multiplying both equations with minus 1 we get minus pi upon 2 plus pi upon 2 to the cube into 1 upon 2 factorial plus pi by 2 to the power 5 into 1 upon 4 factorial minus pi upon 2 to the power 7. Oh, sorry. Here we get minus, here we get plus. Into 1 upon 6 factorial minus it goes up to infinity. As we add both sides with pi upon 2, we get the equation 0 plus pi upon 2 is equal to pi upon 2. And as we add here pi upon 2 minus pi upon 2 plus pi upon 2 get cancelled out and the remaining terms remains. So we here write pi upon 2 cube into 1 upon 2 factorial minus pi by 2 to the power 5 into 1 upon 4 factorial plus pi upon 2 to the power 7 into 1 upon 6 factorial minus up to infinity in the same sequence. And this is the term we were asked in the question. Hence sigma n is equal to 1 to infinity minus 1 to the power n plus 1 pi upon 2 n plus 1 upon 2 to the power 2n plus 1 into 2n factorial is equal to pi by 2, as you can see here. And now we see pi upon 2 in the option number C. Hence option C is the right answer. Hopefully the explanation you will understand clearly. In order to watch such content, please share, subscribe and comment this video and the YouTube channel.